This experiment we have to determine the refractive index of a liquid by Wollaston's air film method. So what we are going to do is we have to find the refractive index of a liquid. We are taking water here and we are using the Wollaston air film method. So the apparatus used to a spectrometer. So the spectrometer is here and we need a source of light. The source of light we are using is the sodium lamp source of light, and air film glass container for the experimental liquid. So this is our glass container in which we have water as a liquid whose refractive index we have to measure out, and then we need a air film. So this is the air film. So the structure is like that. We have two glass is placed, and between these two glass plate the air is trapped inside, so that's why it's air film. Okay, so the formula which we are going to use is very simple. Is the refractive index from air to liquid is by cosec theta, and we have to determine this theta, so that we need to find the refractive index of the liquid. The table of observation is here. You can see this is the table of observation. The content is vernier V1 and V2. We already know about vernier and V2 of the spectrometer, and these are the two vernier of the spectrometer, V1 and V2. In the spectrometer we know already, and so the rotation of the air film we have to do in clockwise and anti-clockwise direction. Note down the main scale vernier total reading, and then we get the minus from clockwise to anti-clockwise. We get the value of 2 theta between these two, and using this theta we have to calculate the refractive index of the liquid. And because the temperature will be actually the room temperature at which we are doing this experiment, the setup will be like this. And you can see this is our collimator, through which from the source of the sodium light source will come through the collimator, and this is the container in which our liquid, which is the water in our case, is there, and this air film is placed inside this water, and then we have the telescope. So the procedure is very simple. So light which is falling here, and we have to make sure that this glass is really perpendicular. The air film is really perpendicular, and it's coming to the light is coming to the directly to the telescope. So match the crossfire of the telescope to the light which is coming through this air film. Okay, and note down this reading V1 and V2, the two scales, vernier 1 and vernier 2 for the direct reading. And what I have to do, I have to rotate this glass film. So I have to rotate this glass film, not this container in which our liquid is there. What I am doing is I have to rotate this glass film and try to see the light source which is coming from here. So what will happen that at certain critical angle, if I keep on rotating the glass air film, the light disappears, and the moment you have to do it very carefully, and the moment the light disappears you have to stop, and at that position you have to note the reading of the vernier V1 and V2. So if and that is what I have done is, if I rotating the glass film clockwise, so I'll note the reading in the clockwise direction, which for vernier V1 and V2, the main scale, vernier scale and total reading. Now what I will do, I will again rotate anti-clockwise. I will reach the same direct position, and then again from there we'll go to the anti-clockwise direction, and at certain critical angle the light will again disappear. So I'll note the position of the disappearance of light in the anti-clockwise direction, the reading of main scale, vernier and total for the vernier and V1 and V2, and then we'll take the difference of vernier 1 and vernier 2 individually, and that will give us the value of 2 theta and the mean value of theta, and we will use that theta here to calculate the refractive index of the liquid. So the setup will look like this. So we have the telescope and the collimator through which the light source is coming. This is the slit here, and the light source will go into this slit and will come from here to the telescope. I'll focus the telescope so that this collimator as well as telescope, so that the slit becomes very narrow and sharp, and try to coincide this crosswire of this telescope to the slit. Then what I will do is level this position, and I'll put this liquid in between, okay, and then I will try to, there's some arrangement is made so that I will put through this arrangement this air film inside this box, okay. And then what I will do, I will try to move once I put this air film should not touch the base of the glass. It has to be near. We'll try to use this screw here, and what I will do is, like, I will rotate this glass, where you can see the rotation of the glass. I don't have to rotate this the whole the box. I just have to rotate the glass plate, okay. Rotate the glass plate, okay. You can see, because I am rotating in anti-clockwise direction, I'll try to see the moment the light disappears. I will note this scale V1 and V2, and then again I will come to the original position, direct position, and then rotate the air film in the clockwise direction, and the moment the light disappears, we will note this V1 and V2 scale. And this is what I had told you earlier, and then we will take the difference, noting down all the readings here, vernier V1 and V2. Take the reading of 2 theta and theta and put it there in the formula. The refractive index from air to liquid is cosec theta, and this is all about the refractive index of the given liquid, which is water in our case. Thank you.